So, good evening, all of you. Today, our topic is like the same dimensional formula, physical quantities having the same dimensional formula. So, we'll look for these four types which have the same dimensional formula. So, let's figure out. Okay. So, the first one is you can see the frequency. So, frequency, you know that it's like number of occurrence in second, you can say. So it is what 1 by t. Okay. Okay. 1 by t means if we talk about m over here, m is nothing but 0, l is 0, and t is what? Negative. Okay. Similarly, angular frequency, as you know, all know the formula for angular frequency, which is the 2 pi by t, right? So angular displacement per unit taken time, right? It's the angular frequency. Right? So, all right. So this is what you know that this is the there is a formula for this 2 pi, which is the displacement, is dimensionless. Okay. So we'll have this only, right? So again, for this one also we can write as what? M0, L0, and T minus 1. Is it fine? Okay. Are you comfortable with this? Okay. Now we have the angular velocity. So angular velocity is nothing but the angular displacement in per unit time. Okay. So for which angular velocity is represented by omega only. So this is what the del theta by the del t. Why we have used the theta? Because the angular velocity is makes an angle, right? It's a circular path, okay? So made angle, some particular angle, 0, 30, 40, 60, and so on. So this is what the del theta. So unit of del theta is again the unit length. So we have the t only. So for this one also we can write as M0, L0, and T minus 1. Are you fine with this, which I am writing? If any doubts, just write in the comment, okay? So let's move on to my fourth physical quantities. So let's see if it is having the same. Okay. Alright, so you know that del V is what? The velocity. So formula for a dimensional formula for the del V, can we write this L T minus 1, right? And similarly for the del S, can we write L? Is it fine for you? Okay. Now L will cancel out, right? Okay. So for this one also, what we can write is M0, L is again 0, and what is remaining? T minus 1. Okay. So we can conclude that frequency, angular frequency, angular velocity, and the last one is velocity gradient. So these all four physical quantities have same dimensional formula, which is M0, L0, and T minus 1. Okay. Alright. Just have a look for a second. We'll come to the next quantities which have the same dimensional formula. Okay. Just have a look. Alright, so here is the 7 physical units which have again the same dimensional formula. Okay, although the terms are different, but they are all same. Okay, let's see how. Okay, so force. Okay, you know the dimensional formula for the force. For the force is what? What is the dimensional formula for forces? The force is what? Mass into acceleration, okay? So the mass into acceleration. Okay. So let us calculate it as mass. So mass is what? Kg, and acceleration. Acceleration is what? Change in velocity or in time. Okay. So change in velocity. Velocity is what? Meter per second square, isn't it? Or if you change it further, you will get kg. Oh my God. Kg meter per second, or you can write it as m l square, ml t minus 2, right? Am I correct? Yes. So this is what we can write for the force. Okay. So let us see. For the force is we have m l t minus 2, and we have what? The displacement. So what is the displacement? Displacement you can write as L, right? And when we calculate it, you will get as m L2 t minus 2, right? This is the dimensional formula for the work. Okay. Now for the heat. So heat is a type of energy, and energy is nothing but a work. Alright. So what is work? Think for a second. You see, it was just written over here. What is work? Work is what? Force to displacement. Force into distance, right? So how much force is applied to a particular area, to a particular distance? That is what work done. Okay. So again, we can write for work also here as what? M L2 T minus, sorry, it is I think 2. Okay. Alright. Again, if we talk about potential energy, if you know the formula, it is mgh. And what is m? M is the mass. So for mass, we can write m. For g is the acceleration. Acceleration what? For acceleration, what is the formula for acceleration? Change in velocity per unit time. So it is again, you can write as m is what? 0. L is what? 1, and t minus 2. This is what the formula for this. And this is what L. And final, when we conclude that, we will get as m0 and 1. So m, now L, 2, and t minus 2. So you can see it's the same formula, same dimension formula for potential energy. Similarly, we can see for the kinetic energy, which you know, that mv square. Okay. So half m is what? For m we can write what? M. For L, what is L? L you can write as 1. Think, quick. L is also square, and t minus 2, right? So overall what we can do is, since this is constant term, so the formula we have is ml square t minus 2 for the kinetic energy. Similarly, for so for this one also, we can write as same as m L2 t minus 2, because internal energy can be anything, right? It can be the potential or kinetic energy also. Okay. Now for the torque. Okay. So for the torque is what? Again, The angular acceleration. So what is the angular acceleration? Angular acceleration is what? Angular displacement, which is you can say angular displacement is what? 2 pi. And so for frequency you know that 1 by t, and again t, so it is a t square. And now for I, so what is I? I is a moment of inertia. So the moment of inertia is what? Mass into radius of gyration, which is ml square. So for this one, it is somewhere as ml square. So finally we can write as ml square t minus 2 for moment of inertia. No, the torque. Okay. Similarly, for the moment of force also we can write as force. What is the unit of force is ml t minus 2 times L, which is again we can write as ml square t minus 2. Okay. So from all this we have seen that the work, heat, potential energy, kinetic energy, internal energy, torque and moment force have the same dimensional formula, which is ml square t minus 2. Okay. So alright. So I'm concluding till here only. Okay. In the next class we will have the new topic. Okay. Thank you so much.